Today we'll be doing Discovering Mathematics 4A Exercise 1.3 questions 2, 3, 4 and 7. Okay, we start with question 2 about noise levels in two schools, School A and School B. I will leave out the calculator skills here and just present to you with the final answer, but on your own you may like to pause the video now to try actually calculate the actual mean and standard deviation for the noise levels in School A and School B. So I just give you the answer for School A. The mean is equals to 65.75 decibels. Okay, decibels is a unit of measure for sound. It measures basically how loud sound is, and standard deviation for School A is 6.70 decibels. For School B, okay, all this should be done with a calculator. I really do urge you to actually pause the video and to try to get these values. Okay, these are exact values, hence I write, normally we will put it correct to 3 significant figures, but in this case, because it's an exact value, so we just leave it as 62.375. The standard deviation, .95 decibels. Okay, now they will ask you, based on the means, in which school is there less noise? Basically, the louder, the higher the decibel means it's more noisy. So in this case, right, I say that since the mean noise level of School B is lower of School A, comma, School B is quieter. For part C they ask for, is there a greater variation? Standard deviation measures spread or variation. In this case, I'll say that there is a greater variation or less consistency. Okay, there is a greater variation in noise level in School A as the standard deviation is higher. Okay, then School B. Okay, you don't need to write it in the exact way that I write it, right, but you will have to basically state which has a greater variation and to actually explain why. So you have to state who has a greater variation and explain why. But the English does not need to be these exact words, so use a bit of your discretion there. You're smart people. Okay, next, question 3. Okay, for question 3, the survey was done to find the number of people living in two apartment blocks, okay, apartment A and apartment B. Same thing, you may like to pause the video to actually try to calculate the mean and standard deviation. If not, I'll just give you the answers now. For apartment A, the mean is equals to apartment A, the mean is 2.33. and the standard deviation is actually 1.25. Correct to 3 significant figures. For building, it's not apartment A, it's building A, sorry. For building B, the mean number of people is 3.67 and the standard deviation is 1.25. Okay, next question. On average, in which building are there more people living in an apartment? Okay, since for the mean of A, okay, is less than the mean of building B. Okay, this is notation. The A bar means that it's the mean of building A. B bar means that this is bar is BAR. Okay, B bar is the mean of building B. So since A bar is less than B bar, okay, that means on the average there are more people living in an apartment in building B. Okay, next one, greater variation. Okay, variation in this case, right, notice that both the standard deviations are the same. So we just state that the variation is the same for both buildings. And we are done for question 3. Next question, question 4. Okay, once again, I really suggest that you go and stop the video now. Okay, maybe I will just tell you how to read the stem and leaf diagram first. Let me show you my copy. Okay, for my copy, see here, 4 and 6 means 46, 4 and 2 means 42, 4 and 7 means 49, 5 and 0 is 50, 5 and 3 is 50, 5 and 4 is 54, 5 and 7 is 57, 6 and 1 is 61, and for this side 7 and 6 is 76, 6 and 5 is 65. So now you will know how to read, okay, this stem and leaf diagram. I think that the confusing part will be the one on the left hand side, but now you know, and knowing is half the battle. Okay, now they ask you to find the mean and SD of the cars passing through junction P and Q. I really suggest for this question especially that you stop, okay, the video, pause, and use your calculator and quickly calculate the mean and standard deviation, right, just in case, just to be sure that you are able to read the stem and leaf diagram correctly and that you are able to calculate the mean and SD for both. If you want to just try out for junction P, that's fine, but at least you do it for one of them at least. Okay, so for junction P, the mean is equals to 57.4 kilometers per hour, and the standard deviation is equals to 9.39 km per hour. For junction Q, the mean is 65.6 km per hour, and the standard deviation is equals to 10.5 km per hour. Now they will ask, okay, compare the speeds of the cars passing through these two junctions using the results in A. Okay, compare in this case, right, if you notice in your O levels especially, this compare questions are actually worth 2 marks. So you probably have to compare two things. So you have to compare the means and standard deviations and use English to string these things together. Okay, let me just give you a brief idea now. Okay, the cars passing through junction Q, okay, the cars passing through junction Q are, if you notice, this mean is higher, are faster, okay, than those passing through B, than those passing through P, as the mean speed of those at passing through junction Q is greater than the mean speed of those passing through junction P. Okay, now to compare standard deviation, I'll say that the spread of speed, okay, the spread speeds of the cars passing through Q is wider as the standard deviation, okay, of cars passing through Q is greater than the standard deviation of those passing through junction P. Like this, you can talk about spread of cars, or you can actually say that the cars passing through junction P have more consistent speeds. I repeat one more time, the cars passing through junction P have more consistent speeds because the standard deviation of P is lower than that of Q. Okay, in this case, I look at it from the point of junction Q. The spread of speeds, okay, through Q is wider than that of P as the standard deviation. So looking at P, I can say that the spread of speeds of the cars passing through P is more narrow, or I can say that the spread, okay, or the speed of cars passing through junction P were more consistent as the standard deviation was lower. So these are just some of the different ways that I can actually write down, okay, the comparison for these two sets of data. Right, now we go on to question 7. Okay, question 7. Okay, question 7. Okay, remember I gave you the explanation of why we take the middle value. Now I just have to find for brand E and brand F. Once again, if it would be best if you actually stop the video, okay, or pause the video rather, and try to find the mean and standard deviation of the tensile strengths. Okay, the mean tensile strength is 140 newtons. The SD is 12.4 newtons for brand F. The mean is equals to 149 newtons, 149 newtons, and the standard deviation is equals to 11.3 newtons. Next one, they tell us to, based on results, which band will you prefer? Okay, in this case, would you want it to be stronger or less strong? Of course, you want it to be stronger, so I will say that I would choose brand F, okay, as the mean tensile strength is higher. If you notice one more thing, the standard deviation of brand F is lesser than that of brand E. Okay, so in this way, right, I can also say that the quality of brand F is higher, is better than brand E, as the tensile strengths, okay, are less or more consistent. Lower standard deviation means that it is more consistent. Okay, so as tensile strengths are more consistent. Alright, and that concludes question 7.